Welcome to the Excited Education channel, the YouTube channel which brings you about mathematics and biology. I would like to wish each and everybody who is watching this video to make subscribe, comment, share and like, such that he or she can follow me step by step according to the video that I would like to upload on my channel. So, I'm very willing that you are watching me very well. I wish you a success in my modules. Just subscribe, comment, share and like for more following videos. Welcome to the my videos.
As I said, the first step we have to think about is the format or the form of the integration. The integration format is denoted by integral of x from n dx, where you have to think that each result we get it in the indefinite integrals by taking this x power n with respect to n, as I said, with the exponential properties. Then if I take n, then multiply, add 1. I divide this power also by taking n plus 1 divided by x power n plus 1 and divided by n plus 1. So let us see that if you finish to work at this, you have to know that it is in form of the indefinite integrals. And indefinite integrals, you know that we had to add the arbitrary constant. Arbitrary constant is c. So this is the form of the integration where you have to use which one we are going to help or to assist us to work out the substitution method. But it's not one property, but you have to add another property where you have to know that the integration, this is number 1 and number 2. You have to know that if you take the integration of e power x, as I said in the first session, this will be equal to e power x. As I said in exponential, if you take e power x and you make the derivative, its integration, it not changes. And even if you derive this, it doesn't change. Remain e power x, then add the arbitrary constant c. So another step, another property is that if you have integral of ax dx, this will be equal to what you have to think about here. You have to know that this will be equal to a for x over ln of a. Then, as I said, for ax and ax, they have the difference. You know that is the exponential form, even this is the power form. Where it is here, it is an unknown a, but it's the element of real number, where it is the known letter. This letter a have its known value. So here you know that you have to think about also the constant arbitrary. This arbitrary constant, it's, as I said in the last session, you add this c in the solving out the indefinite integrations. So let us take an example of the integration by substitution. So example, example number 1, we have integration of e power 2x then dx. This is one example. We are going to integrate this by using the substitution method, and you have to consider these 3 properties and even additional properties that you have seen in the last video. So here you have to think about that this is the 2 function. This is the exponential and the polynomial. Where is the exponential and what is the polynomial? This is the polynomial and this is what we call the exponential. So with the heading value 2. Here you have to know that in solving this form, you have to know by using the substitution method. You have to know that let this function, polynomial function, 2x equal to t. So after letting this 2x to be equal to t, you have to make, as I said, the point of the differentiation. As I said, the integration is the inverse of the differentiation. In this function also, it must to memorize about the differentiation properties, as I said. So here you have to make sure that you have to apply both sides the derivative. Here it will be 2x dx and The derivative of 2x is equal to 2 dx, which is equal to dt. And this will be equal to dx, convert out to dx. Dx will be equal to dt, then divided by 2. This is our dx. We let this. So after this, or after converting this, you have to know about replacement, or how can use this to replace with respect to dx, the dt. So here we have the integral of e power 2x, then dx. This will be equal to the integral of e, then you have here that t is equal to 2x. This is e power 10, yes? And this is 2x, this is 10. As I said, 2x is equal to 10. Then after this, you have to find what is the value of dx. This dx is equal to dt over 2. Then you have to write dt over 2. Isn't it so? Okay, I think you have following me and you have to understand this step. After using this step, you have to think about also this will be equal to. This is dt over 2. It means it is 1 over 2 times dt. You take this constant aside. According to the property we have in the integration, this will be equal to 1 over 2. Then integral of e power 10. Yes. Then dt. So after this, we find that e power 10 derivative is equal to e power 10, as we have it here in the property. E power x dx is equal to e power x plus c constant. So here this will be equal to, then integral of e power 2x then dx will be equal to 1 over 2, then times, this is 1 over 2, the integration of this one with respect to dt, this will be equal to e power 10 as we said, e then power 10. So here we have to know that then to add this c as a constant, this c as the arbitrary constant, we add it on the solving out the indefinite integrals. After, this is not our final answer. We have to think about how we postulate the final answer. Then the final answer will be postulated by writing this. The integral of e power 2x then dx will be equal to 1 over 2. Replace t with respect to 2x. Then e power 2x then plus c. This is our final answer. The integration of e power 2x dx is equal to 1 over 2 e power 2x plus c arbitrary constant. This is then our solution. Dear students, I think I've heard about this first example or first exercise about how to compute the integration of 2 power 2x e power 2x dx, then by using the substitution method. The reason why I call it the substitution method, you see here, we let this, and after letting this, what we let, we substitute it in our integration function. So let us see the next example. For the next example, we have this is number 1, then number 2. We have the integral, yes, of e 5x plus 3, then dx. So this is another example. We are going to compute this integration for by using the substitution method. So here, as I said, you have to know that if the integration question, or if a teacher provides you a question, before you react on that question, think about how many types of the function are included in that integration function. For instance, here, e power 5x plus 3 dx. This comprises the polynomial and the exponential. Yes? So here, solution. Let then 5x plus 3 equal to p. Yes? For letting this, you cannot write only t, but you can write any letter A, B, C, D, F up to Z. Let us write x plus 3, which is equal to p, be our rate. So, as I said, you apply both sides the derivative. If you have the derivative, both sides will be 5x plus 3 d is respect to dx, then which is equal to d is respect to dp. So here this will be equal to this will be equal to 5 dx, which is equal to dp. So here we will convert about dx, then dx will be equal to dp, then over 5. After computing this, we have to think about how we can replace this dx in our question. Then we have the integral of e power 5x plus 3 dx. This will be equal to, our dx is equal to dp over 5, and 5x plus 3 is equal to p. Then will be the integral of e power p, then times this dp, and our dp is this dx is dp over 5. So, after computing this one, this is like 1 over 5. This will be equal to 1 over 5 integral of ep times dp. And this will be equal to 1 over 5, then times e power p, then plus constant c. Then, if you have p as its value, this will be equal to 1 over 5 times e, as you said, p is equal to 5x plus 3, 5x plus 3, then plus c constant. This is our solution. So, this is the second example, how to compute substitution method. In the integration process, we have noted that we rate according to the type of function you have, whether it is polynomial or whether it is exponential. So, let us see another example. And it will be it will be integration of x power 3 then number 3 we have integration of x power 3 divided by x minus 1 power 2 then dx. This is another example. I tried to change the form because we have heard about this form of e power x and what and whatever, but let us use this polynomial function x power 3 with degree 2 and degree 1. For here, what we have to think about, we let one of the function there. And let us let x minus 1 be equal to 10. Then dx minus 1 will be equal to d10. Then dx will be equal to d10. This is our function we have here. Then if you let that x minus 1 equal to 10, and we know that if x minus 1 equal to 10, then 10 will be equal to 1 minus x. Isn't it so? Yes. So, let us replace or substitute in our function of integral of x power 3 over x minus 1, then squared dx. This will be equal to integral x, the value of x. This is the value of 10, yes. Then the value of x will be equal to 10 plus 1. Then here we write x power 3, we take t plus 1 then power 3 over our x minus 1 is equal to 10 squared, then d, our dx is equal to d10. This is how we place this. Then after placing this, we have to compute this, where we will enlarge this. Then t plus 1 over 3 is equal to t plus 1 squared times t plus 1. And this will be equal to t power 3, yes, plus, by using the factorization, plus 3t squared. Then after this, plus 3t, then plus 1. This is the value of t plus 1 over 3. After this, take this value and then you press it or substitute it in this function. Here we get integral of t power 3 plus 3t squared, then plus 3t, then plus 1, yes, dt, then divided by t squared. After this, we have to, if this is the common denominator, if we have this as a common denominator, and we have term 1, term 2, term 3, and term 4, we have to divide both sides with t squared for this and this and this. With respect to our property, we have the properties of integration. If you have the integral of f of x1, f of x2, plus blah blah to up to f of xn dx, you have to make the addition or integration of the addition of those respective functions. As I said, you have to know that it is integral of t power 3 over t squared, then plus 3t squared over t squared, then plus 3t over t squared, then plus 1 over t squared, then dt. After here, we have to know that it will be integral of t power 3 over t squared dt plus integral of 3t squared over t squared dt, then plus 3 integral of 3t over t squared dt, then plus integral of 1 over t squared, then dt. This is how we expand our question. After this, it will be simple to each and everybody who is solving this question if we just separate this by multiplying the integration sign in the respective functions from the highest degree to the lowest degree. After here, we apply our property of the derivative. As I said here, the integral of x power n will be equal to xn plus 1. Then here it will be t power 3, then t power 2. This will goes with this and the remain is the 3 only t. This will be equal to integral of t dt, yes, and plus this will goes with this one, then integral of 3 dt, then plus here this will goes here remains with t, then integral of 3 over t, yes, dt, then plus the integral of 1 over t squared dt. So be attentive and follow please. Here, after solving this one, we have to compute our property. We are going to apply our property in this step in order to solve out this question. Here, you know that the integral of t dt, this one power 1. This is at least it's like a power 1. Then we have to add 1 and divide by n plus 1. Then here will be equal to t, then 1 plus 1, then over 1, then plus 1. Yes? And after this will be equal to 3 yes, dt plus 10 dt, yes, here for this, think about also the property of the integration with respect to its differentiation and with respect to the integration process, where we apply the ln, and here this will be equal to t squared over 2, yes, plus 3k, yes, then plus 3 times, we find that the integral of 1 over x or 1 over 10, 1 over respective variable, it is equal to ln of absolute value of that unknown. I think I've had here. After that, here we add t power minus 2. We have to add here 1 and divided by minus 2. This here is equal to minus 1. Yes, minus 1 over minus 1. Yes, minus t. Then minus 1. Yes, over minus. Here we add the constant c. So we are approaching to the end of the question, but as soon as possible. Here we will get t squared over 2, then plus 3t plus 3 ln of absolute value of t, then plus minus t. This is equal to 1. 1 of minus t. Writing t minus, it looks like the same. Writing 1 of minus t. Then plus c constant. Here, I think it's like looks like the final. And we know that for this, here if you have t squared over 2 plus 3t plus 3 ln of modulus t, then minus 1 over t plus c, and you know that where t equal to x minus 1, then we get x minus 1 squared over 2 plus 3 x minus 1 plus 3 ln of x minus 1 minus 1 over x minus 1, then plus c arbitrary values. This is our solution of our question. So I think this is the end of the method of integration by substitution. Thank you for watching me. I wish you will do better for the next session, where we will look about the integration by elimination, and we look about the integration by other different ways of solving this type of different questions or different functions of the integration. Thank you for watching me. I'm Chaimi as usual on the Excited Education channel. See you in the next session.
Thank you for watching my video. I'm Chaimi as usual from the YouTube channel called Excited Education channel. I wish you have enjoyed my video. So for more videos coming, I would like also to requesting you humbly, just make subscribe, comment, share and like, even post on different social medias, such that each and everybody can gain from the what Excited Education channel provide on the YouTube. So thank you for watching me. May God bless you and your family.